This video is about Finnish law's rules of finding the limits of some different products and quotients. Let's start with an example. Suppose that the limit as x goes to 7 of f of x is so 30, and the limit as goes to the 7 of a of x is 2. X goes to 7 of f of x divided by negative 3 times of x, with which each of x is heading towards so 30 and of x heading towards 2. It makes sense that the quotient should head toward 30 divided by negative 3 times 2 or negative 5. In calculating this limit by plugging in numbers for the components, we were using the limits rules, which are now stated. Suppose that c is the constant, just some number, and that the limits as x goes to a of f of x and a of x exists at finite number is not limits that are infinity or negative infinity. Then the limit of the sum of f of x plus g of x is equal to the limit of f of x plus the limit of x. In other words, the limit of the sum is the sum of the limits. Similarly, the limits of the difference is the difference of the limits. The limits of c times of x is just c times the limit of fx, and the limit of the product is the product of the limits. The limit of the quotient is the quotient of the limits, provided that the limit of a of x is not equal to 0. Since we cannot divide by 0, let us use these limits laws in example to find the limit. As x goes to 2 of x squared plus 3 plus is divided 6 divided by x plus 9. Well, the limit rule about quotients allows us to rewrite this limit of quotient as quotient of limits, provided that the limit of the numerator and denominator exist and that the limit of the denominator is not 0. But we will see in a moment that the numerator as a sum of limits, and we can rewrite the limit in the denominator also as a sum of limits. Next, x of the element is that because x squared is the real x times x, and so the limit really is the limit of x times x, which by the product rule is the limit of x times the limit of x, which is the limit of x quantity squared. Going back to the original problem, we can now use the limit rule about multiplying by a constant to rewrite the limit of 3 times x as 3 times the limit of x, and I will just carry the rest forward. Now that we have got things broken down into bit-sized pieces, we note that the limit as x goes to 2 of x is just 2 because as heads towards 2x heads toward 2, so we can replace all these limits of access by just the number 2, so we get 2 squared plus 3 times 2. Now note that the limit as x goes to 2 of 6, 6 does not have any x in it, so as x2 heads toward to 6 days. And 6, and the limits here just 6. So in my original problem, I can replace the set limits of x with the 6, and the denominator here I get plus 9. And after little arithmetic, this simplified to 16 over 11. Notice that we could have gotten this answer a lot faster just by substituting in the value of the 2 into our original expression. And in fact, that the beauty of the lemon laws, they allows us to evaluate limits of rational function just by plugging in the number that x is going. In that number does not make the denominator 0. It is not nearly too simple. When plugging in the value does make the done at 0. And in the future, we will technique of hand